Okay, so good morning everyone, and welcome to the course Statistical Inference, which is SI 402 in the spring semester. Everyone can hear me, right?
Yes, sir.
Yes,
And
sir.
also can see the board.
Yes, sir.
Okay, so before starting the lectures, so let me go over the course outline briefly. So these are the lecture times. And also I request all of you to mute your microphone. Okay, so these are the three lectures. These are the schedule for three lectures, and there is one tutorial or the discussion which is on Wednesdays, and that is between 8:30 and 9:25. Okay, so maybe later I will try to change the timings of the lectures a little bit, and maybe regarding that I will send an email. Okay, because I want to change this timing. This one is pretty early for me.
Hello, good morning, sir.
Yeah, good morning.
Sir, this is Srihari. And I had an inconvenience with the tutorial slot. Actually, the tutorial slot is clashing with one of my core course slots.
Okay.
Is it possible to change it?
So I don't know. I cannot promise you right now, but maybe I'll try to change it because I also want to change this time. So maybe I'll send an email to all of you regarding the change of this tutorial and also change of this lecture. And then if everyone agrees, then maybe I can change.
Thank you.
Okay. And another thing is that so I will go through the examples and the applications of the underlying theorems in the lectures. So in the tutorials, I will ask you guys whether you have any problem regarding understanding of the lectures, or you have any problem that you cannot solve. Then I will go through those problems and try to solve them. And maybe sometimes I will take extra lectures during tutorial. Okay. So if any one of you does not have any question, I request you to mute your microphone. Okay. So these are the lecture time and the tutorial time for the time being. Maybe I'll change a bit later. And so there are few books that I am going to follow. So you can simply look into the book by Cassel and Berger. The spellings are right. So this is the textbook, but so the approach of this book is kind of non-major theoretical. So I will try to take few things from here and try to also take few things from other books. So the next one is the book by Jun Shao. So I will take many things regarding the first part of the course from this book. So this is the mathematical statistics. The third one is the book by, I think, Harvish. So this book, I think, so all the books that I have written in the course outline. So this book is the hardest one, and also this is the most concrete book among all the books. So if someone wants to study statistical inference rigorously, then one should read this book, the book by Scarvis. Okay, so I'll take few things regarding the testing of hypothesis from Scarvis, and later I will take few asymptotic things, asymptotic results regarding M estimation or different asymptotic tests. So I'll take few things from this book, the book by Booz and Stephens. Okay. So these are the main references. And if you want to read statistical inference, then this book is the most famous one, because this book is the most famous one, because this is very easy to read book, and also the approach is non-method theoretical. Okay, and there are a few other books I should have written. So one is the book by Lehman, and another one is that Lehman and Roman. So I'm not going to follow this book, but I will try to. I will take few things from Lehman and Roman. So mostly I will cover all the things from these 5 books actually. 1, 2, 3, 4, and these 5. Okay. Okay. So now regarding the lectures and lecture materials. So I am going to upload the lecture materials right after the lectures in the course website, and you can find the course website in the course outline, and I have already shared the link of the course website with you in an email, so that is fine. And mostly I will deliver the lectures through Zoom, and I will consider this Zoom link that I have already sent you. I'll try to maintain the same link for every lecture and the tutorial. And the next one is the homework policy. So I'm going to assign homework on Tuesdays, and that will be due on next Thursday. So that means the first assignment will be posted on next Tuesday, and that will be due on next Thursday. Okay, and you will have one assignment in every 2 weeks, and there will be a window of time. So as I have written in the course outline, it's like 2 p.m. to 5 p.m. on Thursdays when you have to submit the assignment through email. Okay, so I will only consider of grading your assignment if you send your assignments between 2 p.m. and 5 p.m. on Thursdays. Okay, otherwise I am not going to grade, because it will be very difficult for me to check all the emails and download your assignments if you send any arbitrary time. Okay, so that is another thing regarding assignment. And one more thing is that I will randomly choose one or two problems from every assignment and grade only those. Okay. So although I'll post the solution of all the problems in the assignment, I'll only give you points based on randomly chosen one or two problems from each assignment. Okay, so next one is the exam policy. So exam policy, there are two things, two parts of exam. One is quizzes and another one is the exams, the midterm and the final. Regarding the quizzes, there will be less than equal to 4 quizzes in this course, and the quizzes will not be so will be I'll tell you the date and time of the quiz beforehand. So that is regarding quizzes, and there will be 2 exams. One is midterm, another one is final, and the exams and the quizzes, they may be open book or closed book. If they are open book, then you know the drill actually. So you can have all the notes of yours in front of you while giving the exams. Else, if the exam is closed book, then you are allowed to bring or have 2 A4 sheet pages in each of the quizzes and exams, and both sides of those A4 sheets you can use for formulas or any other thing. Okay. And another important thing regarding the exams and quizzes is that, first of all, I'm going to take these quizzes and exams through Zoom, most likely. So that means, again, I will send a link regarding the exam and quiz, and you will simply switch on your computer or mobile, and then you will just write the exam. So that's it. That's how I'm going to take the quizzes and exams, and I'll tell you the date and time of the exams and the quizzes beforehand. Okay, and one more important thing is that since all the things are running in online mode, so it's very easy to cheat actually, copy from someone. So if I find someone cheating or copying from someone else, I'll give both of you guys actually. I'll give 0. Okay. And maybe if during the exam, if I find someone cheating, then maybe I'll bring that thing to the academic authorities of IIT Bombay, and then maybe some penalty will be there regarding that. So be aware of cheating. And email is regarding email, so you can always send me email regarding any query, and I will definitely answer to your email. And regarding the grades division is so first of all, there will be no relative grading. The grading will be absolute, and so, and also you can find so I should tell this. So it's the 20% is homework, 20% is quiz, 20% is midterm, and the 20% is final, or 40% is final, or 20% final plus 20% project. So this thing I am going to decide in the later half of the course. So whether the final will be of 40% or there will be a project which consists of the 20% of the whole 100. Okay, that I am going to decide later. So, but this is kind of the division. So based on this, the grading will be absolute, and whatever you get out of 100, based on that, you will get the ultimate grade in this course. And the grades that you will get based on your numbers, so that the division is given in course outline. You can look into that. And the last thing is the tentative class schedule. So in the first part, I will mostly cover the things that you have already learned in BSc. This sufficiency, completeness, then ancillary. Ancillary, I think you have not learned yet. Then the UMBV, CRLV, and other inequalities, and then the testing. So this thing I will cover, which you have already seen. Most of the things you have already seen in BSc, and later in the later half, I will try to cover few things from the asymptotic inference. So mainly I will try to cover M estimation and different tests. There are three very important asymptotic tests, which are the one of which you already know, that is the large sample test, or sorry, that is the likelihood ratio test that you have already seen in BSc. And there are other tests. One of the other two tests is the score test by Rao, and another one is the wall test by Abraham Wald. So those three tests are very important in inference, because those tests are very general tests, and those require very few assumptions. That is the most important thing. So all of these things, these are called the classical inference, a part of classical inference. And this all the things in the classical inference require very heavy assumptions. So you need some, in most of the situations, you need some assumption of the underlying distribution. But in asymptotic inference, you do not need those type of heavy conditions. So you only need the existence of some moment or the symmetry of the distribution, those things. So this asymptotic inference is more towards the non-parametric inference. So non-parametric, so there are two things that you know, I think. One is the parametric, another one is non-parametric. So in parametric one, you either know something about the underlying distribution, or you do not know. You know something about the moment or symmetry or something. So whenever you know many things about the underlying distribution, then it's simply the classical inference, and all these things are generally part of that classical inference. But whenever you do not have many assumptions, so then you have to build your tool or technique using asymptotic justification. Okay, and then this asymptotic inference comes. Okay, and I don't think I'll be able to get time after covering all these things. But if I'll able to cover all these things, then later in the maybe last week or so, I'll give you a flavor of Bootstrap. Okay, so Bootstrap is the a modern technique of inference, and it requires very less assumption. And whenever even the central limit, you already know the central limit theorem. Whenever the central limit theorem fails, then also Bootstrap works. So that's why the Bootstrap is very important. But I don't know if I will be able to get time after covering all these things. If I get time, I will try to give some flavor of Bootstrap. Okay. So this is more or less the course outline. So does anyone have any question?
Sir, I do have few questions from the assignments part.
Yeah.
So on an average, how many questions will be given out in a particular assignment?
It depends actually. Maybe you can think of 7 or 8, around 7 or 8.
Okay.
But you will get 2 weeks for one assignment, so that will be enough, right?
Okay. So like, can you relax, like picking a certain, like you said, like you'll pick a certain question and then grade according to that. Can that be relaxed a bit?
Relax that actually, because
okay.
So there are maybe around 40 people. You guys.
No, my concern is Yeah, so my concern is, suppose the assignments is of a larger size, like 10 questions, let's say,
Yeah.
and suppose by chance we do a question wrong and it really affects the effort we put in. So that's my concern I have.
No. So you do not need to worry, because even if I am telling you that I'll randomly pick the questions, but I'll try to take those questions which are easier than the
Okay.
others. So
Fine.
do not worry about it.
Okay.
Any other
And,
question?
so there is one more thing about the uploading time frame. So can you extend the time frame or like consider some other means of submitting? Like strict deadline is fine, but just the 3 hour time frame for uploading that, can that be
Because
relaxed?
if you guys send me emails arbitrary at arbitrary times, then maybe it will be very difficult to track all the assignments for me, right? So that's why
So
I'm giving you 3 hours window. 3 hours of window is very wide, right?
no, sometimes, okay, if there are some
Yeah.
exceptional cases, you can
Yeah.
consider it.
Sometimes if the internet does not work or if something happens, then maybe I'll consider that. But
Okay.
in the beginning, I'll be strict about that window.
Yeah, fine. In that
Maybe
case, it's
later
fine.
I will relax that, but in the beginning, I'll be strict.
Yeah, sure. Yeah, thank you.
So,
Any other question or comment?
I have one suggestion. In the last thing, you can make a Google Drive link, and that will be easier to maintain also
Regarding what?
for submission of assignments.
Okay. Yeah, that may be a good suggestion actually. I'll think of that, and I have to learn actually how to do all these things. Yeah, I'll check that, and maybe
Okay.
if that is convenient for all of you, then maybe I'll consider it.
Sure, sir.
Any other question, comment?
Sir, in the 40% weightage, sir, do we have any do we have any preference whether we want to do the project and 20% on that or either or do I mean
No. You do not have any choice. Whatever I say, you have to follow that.
okay, sir.
Okay. And I'll decide this thing in the later half of the course. And also regarding the project, this project, if I assign you some project, so that project will be rigorous. So you have to do something for your own actually regarding the project. So it will not be so compared with the final exam. I don't know whether that will be easier or not. Maybe that will be harder to do the project.
Yes, sir.
Okay. Any other question?
I might have missed this part, but on the course website, will only the lecture notes be uploaded, or the recorded lecture videos will also be uploaded
No.
there?
So I'll upload both actually. So I'll upload the videos and also the lecture notes separately.
Okay, thank you.
And although I am going to upload the lecture notes, I'll recommend you guys to read some book. Just pick one book from the list and try to read that, because there is comparison with if you compare the lecture note with reading a book, there is no comparison. It's any day it's better to read a book. Okay. So any other thing, any other comment or any question? Okay, fine. Okay, one more thing is that so I'm not going to I'm not going to consider the total measure theoretic approach in this inference, but I will try to give you guys some flavor of measure theory. Okay, because that will be easier for me also to prove something. Okay, so let's start. Okay, so whenever you whenever someone of you consider statistics or the subject statistics, what are the parts of these statistics or the statistical analysis? What are the parts? Can anyone tell me? What is step 1? There are a few steps, right? What is the first step? So whenever you are doing some statistical analysis, there are some steps, right?
Problem statement.
Yeah, the first one is
Problem statement.
no, problem statement is always, so if you already have that statement, so maybe some organization wants to comment or wants to conclude something about the some feature of something. Okay, so that is already given, so that is not part of the study. Now given that problem, so there are few steps through which you will go and you will conclude or infer something about the underlying feature or something. Okay, so what is the first step? So first step is obvious, right?
Data collection.
Data collection, right? So collection of data. So in collection of data, what are the things generally come? So you generally you have to design the experiment so that you will get some data which has some inherent randomness. So here these things generally comes as sample survey, the design of experiment. So these parts of statistics generally deal with collection of data. Next one, what is the next one? So next one is given step 1. So step 1 means already the data is in your hand. So now the step 2, what is the step 2?
To create a model or to fit a model.
What?
Based to create a model or to fit a model based on the sample collected.
So that is in step 3 actually.
Analysis of the data. Tabulation.
Tabulation. So you have already learned. What is the first thing you have learned in statistics? The descriptive statistics, right? So that means you will simply plot the data or you will simply tabulate the data. You will find a frequency table of the data, and based on that, you will somehow guess what should be the model. Okay, or what should be the model, or how you can say something about the underlying feature. This is the next second part. Third part is that you have already said, it's the modeling. So this modeling part is sometimes the part of the statistical inference, or maybe you can split it. Let's split it. And now given all these three, the last part is the statistical inference. Right? So that means first, given the problem, you will collect the data based on some statistical design or something. Then given whenever you have the data in your hand, you will plot the data, you will find the frequency table. That means you will find some measure of the descriptive statistics, and based on which you will try to guess the model. And the third one is the modeling. So based on this, you will somehow guess the model. And the last one, which is simply after now you have the model, you have the data. Based on these two, you will somehow find a tool which will, based on which you can somehow infer about the underlying features or the parameters of this model based on this data, right? That's how these are the steps of statistical analysis. So now in this course, you will simply or we will simply consider this fourth step, which is simply statistical inference. So this statistical inference is nothing but a bridge between the data and the model. So that means in the model there are a few parameters and you want to infer something about the parameter or the model and based on the data. So this statistical inference is nothing but a bridge between this data and the model. Okay. Okay. So now, so in stat inference, so what we need to do, we need to conclude something about the population from the sample, right? So we are going this direction in statistical inference. And recall in collection of data, you generally go in this direction. So you have a population, and from there you collect the data. And in statistical inference, you have to go in the reverse direction. So based on the sample, you want to infer some feature about the population. Okay. So so suppose this omega is the population. So population is the main thing actually. Main thing, or it's the universal set. Okay. So now, so you want to infer or conclude some feature about the population, right? Some feature. So first you have to identify the feature based on the already posed question that you have, already posed problem that you have. So for example, if you want to infer about the say average income of some group, or maybe the average height of say the population of India. So in that case, what you need a variable x, which will take this omega, which is a person, and simply give the say if you are considering the height, average height of the person omega, right? You need some variable because you are not interested about any feature of the population. You are interested about the height of that population. So that means you need a variable which will give the height of the underlying person. So that means x of omega, where omega is a person. So this x omega is nothing but the height of the person omega. So this x is called a random variable. And this is nothing but a function from omega to r. And whenever you are considering a collection of say x1, x2 up to xn, it may be rn. But let's consider the univariate case. So it's a random variable is simply a function from the sample space. This omega is called the sample space also, because you are taking the samples right from this space, from this population. So that's why it's called the sample space, or it's also the universal set. So from here to r, so that is a random variable, but or not but, provided x is measurable. Do you know what measurability is? Have you learned before? Yes.
Yes, sir. I know what is measurable.
Okay.
I think the mathematics students in this group, they know what is measurability. I can't say for statistics, guys.
Okay, so anyone from the statistics group, you know what measurability is? Okay, let me briefly describe what measurability is. Okay, so so that means given a population. So right now I am considering the population. I will come to the sample later. So given a population, suppose you are interested in the height of that population. So then you need some variable which will give the height of the underlying person, and that variable is nothing but a random variable, and that variable is from the universal set to R. And so now to know about this omega, okay, this universal set, what you need another another set or another collection of sets, which you simply call the sigma algebra. So what is this? So it's kind of it's, you can think of the sigma algebra as a magnifying glass, and using that magnifying glass you want to know this omega. Okay, so for example, if you say, let's consider this set 1 2 3 4, let's consider smaller one. So if this is omega, so suppose this is omega, then a choice of script f, a choice of sigma algebra is simply the power set of omega. Right? So you know what power set is. Power set is simply the collection of all subsets of omega. That is the power set of omega. So it is giving you the highest magnification of omega. Why? Because you can have any possible combinations of the elements of omega that you can pick from this set, from this collection. So that's why this is the highest magnification you have if you consider this power set. But you may not consider this highest magnification. You can also consider, say here, you can also consider this set. Yeah, only these two. Then actually you are not you are saying that you are not interested in singletons. You are either interested in the null set or the universal set. Okay, so this is another choice of this sigma algebra. This is a choice of sigma algebra, but here the magnification is much lower than this. That's it. Okay, so this sigma algebra is nothing but how much you want the magnification, or how much powerful you want your magnification glass is actually to know this universal set omega. And in general, what should be the properties of this script f? There should be three properties. This omega should belong to script f. Second one, script f should be closed under complementation. That is, A belongs to script f, imply A complement belongs to script f. And the third one is that given the script f is closed under countable union. That is, if you are given a sequence of sets belonging to script f, so always remember that this omega is a set and this script f is a collection of sets or a class of sets. Okay, so if you are given a sequence of sets from script f, then the countable union, so that means simply the union of that sequence will lie in script F. Okay, so these are the three properties of a sigma algebra. So whenever you have some universal set, you also have some sigma algebra associated with that omega. Okay, and that means you have this space omega script F. So now you need another thing. What you need? You need a measure on this space. Why? Why do you need that? Or do you here you only need the probability measure? So instead of this, you want to have this thing. So this is simply the universal set. This is the sigma algebra, and this is a probability measure. So its probability measure is simply the probability. So that means it's simply this p. This p is a function from script F to 0, 1 with two properties. One is probability of null set is 0, and the next one is that if you are given a sequence of sets belonging to script F such that any two sets is disjoint for all I not equal to j, then probability of the union is simply the sum of the probabilities. So you already know, right? If you already know that probability of A union B is simply probability A plus probability B minus probability A intersection B. So whenever A and B are disjoint, then the probability A intersection B is simply probability of null, which is 0 by 1. So that means probability of A union B is simply probability A plus probability B. So instead of the finite number of sets, you need something more. You need to have that property for any countable collection of sets belonging to script F. So this omega is the universal set, which is the population. This script F is the magnification glass through which you are looking into this omega, and that is called the sigma algebra. And the next one, last one, is the probability measure. So there may be some arbitrary measure also, but for the time being and in this course, we will simply consider the probability measure. And this probability measure is simply some function from this sigma algebra to the closed 0, 1 with these two properties. Okay. So that's how things are defined. And instead of calling this omega to be the population or population, instead of calling this omega to be population, from now on, this whole thing, I will call this as the population. And why we need this P? We need this P or this probability measure because whenever we want to infer something about the underlying feature, then there is some degree of uncertainty. And why there is degree of uncertainty? Because if you go and collect the sample again, you may have a completely defined sample, right? So you already have the data, but I am saying if you go and collect the sample again, you will get you may get a completely different data or sample. So that means there is some uncertainty attributed due to that collection of data. To account that uncertainty, we need some randomness, and that randomness is quantified using this measure, this probability measure. Okay. So given a population, we need a magnifying glass, which is the sigma algebra, and then we need a probability measure, which simply quantifies the uncertainty. So for example, in BSc, you have already seen that whenever you want to you want to say find some confidence interval, there is some confidence coefficient, right, or confidence level, and that confidence level is somehow quantifying the uncertainty. So similarly, when you are concluding or you are giving some point estimate, then you generally also give the variance of that estimate, the value of the estimated variance. So that variance quantifies the uncertainty. So to quantify that uncertainty, you need randomness, and that randomness is characterized by this probability measure P. So now, so any question till now? So I'll request, if you do not know about this, about the probability measure or the sigma algebra, I'll request you can look into chapter 1 of Shaw. The Jungshaw's book, you can simply look into chapter 1, and you will learn all the things if you look into this chapter. Okay. So now this is the population. And from here, you have this sample X, and this X is nothing but a function from omega to say R. For the time being, let's consider R. But in general, we say a sample of size n. In that case, we generally consider omega to R to the power of n. Okay.
Excuse me, sir.
Yeah.
Sir, I have a doubt.
Yeah. Go ahead.
Sir, in your notes posted on the course website,
Yeah.
you choose P to be the probability model instead of the probability measure. So, can you explain to us this difference?
No. It's so I am going towards the model. Actually, this is the model. But
Okay.
so first of all, I am defining this P, and this P is nothing but a probability, and this P is probability. That means P is a measure. So that's why it's a probability measure. And next, so what is the aim of statistical inference? The aim of statistical inference is to say something about this probability measure actually, because I am coming to that. So you will understand both of things. Okay, so this is the population, and this is the sample. Sample is simply a function from omega to R such that X is measurable, that is X inverse of B belongs to scripted. For all B belongs to the Borel sigma algebra on R. So does everyone know the Borel sigma algebra? So Borel sigma algebra is simply a sigma algebra. This is the Borel sigma algebra on R. This is nothing but you first look into all open sets of R and then generate the sigma algebra, the smallest sigma algebra, which consists of all the open sets of R. Okay, so that is the Borel sigma algebra. Just search in Google if you do not know, or you can also find that in the chapter 1 of Jungshaw's book. Okay, so this is the definition of a random variable. So x is a random variable defined on omega script fp if x is a function from omega to r and the pre-image of any Borel set belongs to the sigma algebra. The sigma algebra on omega. Okay, so why we need this? We need this restriction. We need this restriction because what we want actually. So we want to find probability of x belonging to some set B, right? For some B subset of R. So just think of x to be a normal random variable. In that case, you want to find the probability that the random variable belongs to some set, right? Some subset of R that you want to find. So in that case, what is this? This is nothing but P of x inverse of B, right? What is this? This is nothing but omega such that x omega belonging to B, right? So that means you are looking into all omega belonging to this capital omega such that x omega belonging to B, which is nothing but omega belongs to capital omega. Omega belongs to x inverse of B. So that's why this x belongs to B is nothing but x inverse of B. So now if this probability, this measure P defined on script f, right? So that means it acts only on the elements of script f. So if this element, this quantities does not belong to script f, then you cannot write this. So that's why you need this restriction. This x inverse of any Borel set lies in script f. Okay. Any question?
मी काय म्हणतो तुम्ही निघायच्या पहिले फोन करा मला किती वाजता निघू 11:30 वाजता या तुम्ही
Can you please mute? Yeah. Okay. So that's why you need this restriction actually. So you need the pre-image of any Borel set lies in script f to define the random variable because you want to find this type of probabilities, and to find these probabilities you simply looking into P probability of x inverse of B. And if this x inverse of B does not lie in script f, then you cannot write this because P acts on script f. So that's why you need this. And one more thing is that this is nothing but P composed of x inverse of B. So simply think of P as a function, x inverse x as a function, or x inverse as a function. Then this G of f of B. So that means G composed of f B, right? And this P composed of x inverse is called the law of the random variable x. And so how you generally define a random variable? How you generally define the distribution of a random variable? Using what? We generally define the distribution of a random variable.
We use the distribution function to
Distribution
define.
function, right? CDF. So and the CDF. So whenever you are writing some random variable and you want to define the distribution of that, then you need the CDF. And what is the CDF? CDF of that random variable at the point x is nothing but this function P composed of x inverse of minus infinity to x closed. This is how the CDF is defined. Okay. So this set, this minus infinity to x closed, is actually a Borel set. So that's why you can write this, and using this you can define the CDF. The CDF is nothing but P composed of x inverse of minus infinity to x, x closed. Okay. So now what is the structure that we have? So we have a sample x, and using this x, we have this space R, dr, and the P composed x inverse. So similar to this, just think of the same thing, whatever I said regarding this triplet. So there is another triplet. So here omega is the population, or here omega is the universal set. Here the real line is the universal set. Here script f is the sigma algebra. Here the Borel sigma algebra on R is the sigma algebra. And here P is the probability measure. Here P composed x inverse is the probability measure on this space. Okay. So using P and using the underlying random variable x, you can have a probability measure on RBR. Okay, and since you are interested, so for example, if x denotes the height of the persons, you are only interested about the height of the persons, not the weight of the persons. So that means you are only interested about this P composed x inverse, not directly this P actually, because there are two things. One is this probability measure P, and another one is the random variable. So this random variable characterizes the underlying feature that you want to infer about. Okay. So that's why instead of this P, actually we are interested about P composed x inverse. This P composed x inverse is a measure on RBR. And since this is a abstract space, and this is a very much simplified space, because you are simply looking into some real numbers here. So that's why it is much easier to work with this triplet rather than this triplet. So sometimes instead of defining this triplet to be a population, sometimes we can also define this triplet as a population, because we are only interested about some feature of the population, and that feature in most of the situation is real value, and that's why you can define this triplet as the population also. Okay. So you will see that whenever you will learn some inferential procedure, then this thing will come, P composed x inverse, not this P. So that means both the things are important, P and x. That means this P is, so this P is called the model actually, and this x is characterizing the feature, the underlying feature. So that means you need this P composed x inverse. So again, since instead of if you define this triplet as a population instead of this triplet, you can also call this P composed x inverse to be the model rather than calling this P as a model. Okay, so it's kind of dubious, but it depends on the underlying structure of the problem actually. So in most of the situations, the underlying feature is real, and you want to infer about that that feature. So you are simply looking into this thing. So for example, whenever you are looking into height, so you know that in most of the situation, the distribution of height is normal, right? That you know. So that means here you simply consider R, dr, and the normal measure, normal probability measure, and that is your population in that case. And based on the collected data, you want to infer about the parameter of that normal model, right? So you are actually looking into this triplet, not this triplet. You are transforming the problem from here to here, and you are looking into this triplet, and the M, let me write the M. So what is the aim? Aim is that to infer about decomposed X inverse based on collected data. So just think of, you do not need to think of this triplet. Just think of this decomposed X inverse to be normal mu1, say. Okay. So for example, say normal mu1. Okay. And then it's simply the parametric model. And here you want to infer about this mu, because this mu characterizes this model. So that's why if you can infer about mu, then you are done. So actually the aim in statistical inference to infer about decomposed X inverse based on the collected data. And the problem somehow gives you what should be your X, and P is always there. Okay. Sorry. So that means the main important thing is P composed X inverse. And the aim of statistical inference is to say something about this P composed X inverse, which is simply the law of X. Okay. Okay. So any question? Fine. So regarding this, regarding sigma algebra and measure, you can simply look into chapter 1 of Junsao's book, and just look into those things. And if you do not understand, you can always ask. Okay. And I believe you understood the basic structure, right? So this triplet is the main important thing, and the aim is to infer about this P composed X inverse based on the observed data. So in the next day, I will begin from here, from this aim, and maybe we will start the sufficiency in the next class. Okay. So any question, any comment?
Sir, I have a request to make.
Yeah, sure.
Sir, the request is to, is it possible to change the tutorial slot since it is clashing with the slot of another course I and some of my friends are doing?
Okay, sure. So sure, in the sense I cannot promise you right now, but I will maybe send an email regarding the change of the Tuesday's lecture and the Wednesday's tutorial. So if everyone agrees, then I am fine with that. Okay.
Okay, sir. Yes.
So I believe you guys do not have any question or anything. So so I have already uploaded lecture 1 and 2. So try to go over the lecture 1 and the first few things of lecture 2. And if you have any question, you can always ask me during tutorial or discussion, or you can also ask me during lecture. That is not a problem.
Sir,
yeah.
In the measurability, you told that we are magnifying on some sigma algebra, but that part was not.
No, that we are magnifying not a sigma algebra. We are magnifying the universal set. So whenever you have a set and you want to learn something about the set, so then what you want? You want to know, say, for example, some singleton regarding that set, or maybe some two elements together of that set. You want to learn about those. To learn about those, you need what you need. You need all possible subsets of that set, of that universal set. So, and that all possible subsets is nothing but the power set. But in many situations, as you will see later, that you do not really need the all possible subsets. You may consider some class of sets which is much smaller than the power set. So that means you need some sigma algebra. That is the first thing. That sigma algebra is somehow using which you are somehow looking into the universal set. And I am just considering the analogy between the sigma algebra and the magnifying glass. because using the sigma algebra, you are simply looking into the universal set, you are magnifying the universal set, nothing else.
Okay.
So just try to go over the chapter 1, not the whole chapter 1, but these parts, this measure and measure, that sigma algebra and the measure, that part. Chapter 1 of June's book. Okay, so maybe that's it for today. In the next lecture, that means on Monday at 11:30, we'll start, and I'll start from this M. Okay. Okay. So bye everyone. Bye.
Thank you, sir.